Welcome. This is the last day of the 12th day of DevRel at Hazelcast. I'm your host today, Fawaz Gali, and I'm very excited to have Ed Sanval for the last session. But also, I'm very excited also to have the London Java community and Abby Leverton. Welcome, Abby. How are you today?
Yeah, really well. Thank you for us. Thanks for having me.
Yeah, it's great. Would you like to talk a little bit about the London Java community and the partnership with Hazelcast?
Sure. As Fawaz has said, my name's Abby. So the London Java community, we are a community of engineers, developers, CTOs. So we're all walks of life, really, who obviously are interested in Java. That's kind of what we're about. Um, And I personally work with a number of communities, including the LJC, and our relationship with Hazelcast is amazing. They're one of our sponsors, so that's always an awesome place to be. So that means we get to do loads of fun events together, including things like this. Um, and yeah, the LJC itself is run by RecWorks. We are a tech recruitment company, but there's a huge difference in the sense that obviously we're always on the lookout for more clients, and some of our best clients have come from community members who recommended RecWorks to their internal talent team. If you want to know more about what we can offer in that side of things, please do get in touch. You can find me on LinkedIn, Twitter, or Slack. My name is as you see it on the screen, and we'd love to continue that conversation with you. But the difference, because I can hear you saying, what's the difference? I don't get it. Well, also, as a company, we really believe that recruitment can be a force for good in the industry beyond just placing people in jobs. We have a particular focus on learning, mentoring, and personal development, and that's where communities like the LJC come into play. If people want to learn and others want to share their knowledge, we are more than happy to connect you through our communities and events like this one. We see this as giving back to those we've worked with in the past, but also paying it forward to those we hope to work with in the future. And again, if you want to know more about any of the communities we run, just get in touch with myself or Helen Lewis or Barry Cranford if you know any of them, and we can take it from there. Thank you so much for joining us this evening. I'm excited to be here.
Yeah, thanks so much, Abby, for you and the whole team at the London Java community. We truly appreciate your efforts towards the community. In fact, it's one of the greatest things to do, actually. We also do ask anyone watching us now live to go and sign up for our 12-day campaign, which is mainly for the community as well, for a chance to win $500 straight away after this session. So we had a run for 12 days, and basically it's very exciting coming to an end, but also we're looking forward to hear from you as well. So if you got any question about this session today, about the London Java community, or even about the previous 11 sessions of DevRel, feel free to leave your questions down below. Make sure also to click on follow as well to get notified when we go live. We have a Twitch session where we do a live stream for coding sessions and office hours. We also have a community Slack where you can also ask questions about Hazelcast and the use or even access to our engineers and solution architects. So with that being said, let's just get things started for this session. I'm quite interested to actually have, they always say, save the best to the last. And this is the last session for 12 days of DevRel. So welcome, Ed. How are you today?
I'm doing fine for us. Thank you very much. Thank you for having me.
Yeah, it's great to have you. And actually, it's very important topic because of the time. Obviously, now the audience will notice about the Black Friday and why this is important. So it's coming like exact time, which is quite crucial for most, app developers and software architects. So this is great topic today. But perhaps you can start, a little bit introduction about yourself, your background, and what you do at Hazelcast.
Yeah, so my name is Ed Sandoval, and I'm the lead AI product manager for Hazelcast. I've been with the company for about a year, and before that, I had a background of product manager at Redis, where I was also in the AI machine learning products. And before that, I also spent some time with Salesforce, again in the product management area, looking at low code, no code, AI, and machine learning for Salesforce products. So that's the Salesforce Einstein team. So Yeah, and the company kind of in Hazelcast, my role is looking after AI machine learning features that help developers build more cool apps, I guess.
Yeah, I think this is quite important, especially with large language models and vector database and all these aspects of, the real-time machine learning as well. So I'm looking forward for this session. But from your experience with Hazelcast, how do you describe the relationship between, machine learning applications and Hazelcast? Where does Hazelcast fit into this picture?
Yeah, well, if you think about it, Hazelcast, for those of you that are not that familiar, you can think of it as a combination of unified way of building a stream processing and a low latency data store. So what does that mean? It means that you have compute and data very fast in the same cluster, and the compute is very, very is partitioned in a way that runs next to your data. So the net result of this is that is high throughput, low latency, and in a system that is, built with fault tolerance and high availability in mind. So this system is solid. So where in general, we see customers using the fast data store, the low latency store, to store features that is used by their models. And we're also starting to see customers using us to run the model next to the data as well. So it's a very exciting time, and we have lots of new features and for the new year. So yeah, I can wait to talk about those in a different session. But today we're going to be looking at a it's low code approach to handle real-time events.
Yeah, that's great to hear. I'm looking forward to this. And I just want to share this big news announcement that Hazelcast is a strong performer for streaming data platform on the 4-star wave. So you will see the link for the report. So feel free to download the report in the comment chat. And with that being said, let's just deep dive into this topic. Over to you, Ned.
Thanks, Fawaz. So let me just share my screen. Let me know when you can see it.
Yeah, we can see it.
Cool. So as I mentioned, the topic for today is a declarative event aggregation for real-time events. It's a very simple approach to use a YAML file to generate code that automatically can calculate aggregations over a stream of events. And we'll unpack what all of this means with a very simple example. So kind of the plan for today is talk about real-time event aggregation in everyday apps, some examples that you might find familiar. And I'll talk about some of the challenges of architecting these into your apps. Then we'll look at our approach of generating automatically code from a YAML file and deploying it to Hazelcast. We'll see a demo of this, and then we'll close off with some more use cases, because the patterns that you see for real-time event aggregation are applicable to a number of industries and a number of use cases. So we'll talk a little bit more about that, and we'll open up for Q&A. So with that in mind, when you think about real-time event aggregations, kind of the classic examples is clickstream processing. So I'm sure that we've all been to apps or websites that show messages similar to what you see on the screen. So you may be in your favorite news app, and you see little messages that come up and say, 50,000 people are viewing this page right now. Or you may be booking your next holiday, and you see that when you find that hotel that you want to book, you get a nudge to say, a little message is nudging you into action saying, this hotel book has been booked several times within the last hour, and as this currently is at a given price. And the same could be happening when you're booking you're renting a car. You see messages that, again, they prompt the user into action. So messages like, in the last 24 hours, over 20 customers have booked a car in this location. So in all of these, the pattern is the same. You're being nudged into action by presenting you with information that is happening as a result of a number of real-time events. So people are viewing or booking or trying to book your products. And there could be thousands of these events happening every second. So your solution must address this throughput challenge, handling that level of events per second, make sense of them, and then present the information back to the user so you can nudge them into action. So that's kind of the very, very common use case. Now, we know that this real-time event aggregation drives up conversion rate and increases user engagement, but at the same time, you need some kind of relatively complex infrastructure to put a scalable solution in place. You need at least 2 clusters, one for stream processing and one for storing the data in memory. And not only that, for the stream processing part, you need kind of a specialized Java stream processing skills, even for some of the simplest projects. So what you will see today with declarative event aggregations is a no-code approach that, given a simple YAML file where you specify what you want to calculate, what aggregations you want to calculate, and generate code and send it to Hazelcast. Hazelcast takes care of scaling with your events. I mean, we'll see today a very a low spec cluster handling thousands of events per second, but you can get the picture that the more power you get to this cluster, obviously the more the ability to scale that will increase. And you will see that in the demo that we'll see today, you can get started with events in JSON format that are available in a Confluent Kafka topic, for example. So with that, let's go into the demo. But before I do that, I just want to explain a little bit the setup that we have for this demo. So what you see on screen is that these events, like somebody viewing a product, it typically comes from some kind of message broker. And in this case, it will be a Confluent Kafka topic. So the event will look something like this. It will be a JSON message that has a user, somebody viewed a product at a particular time at a particular price. That's what an event looks like. The code that we'll generate will handle continuously computing multiple aggregations based on these incoming events. So what these aggregations are, examples could be, how many times for a given product, how many times has it been viewed in the last 5 minutes, in the last hour? What's the average price that people have paid for this particular product in the last 24 hours? So that's the stream processing part of the journey. And then once you compute, you need to serve those calculated values back into an app, then you can show to your customers. So that is relatively the flow of what we will see today. Ultimately, there will be an app that will consume this data and display that to users in real time. So to summarize, what we'll see in this demo, I'll walk you through, is we'll generate code from a YAML file. We'll compile that code and deploy it to Hazelcast. We'll kickstart a stream of events into this Kafka topic. We'll explore the aggregations with SQL, and we'll use this Streamlit app written in Python to display the values that are being continuously calculated. Okay? So let's get into sort of the low-code side of this and show you. First, I'll show you what the events look like before I send them. So as I mentioned, it could be this particular user viewed a product at a point in time at a price. Another event could be some other user view a different product at another time at another price. So these are the examples of events that are happening continuously hitting your app. Now, this YAML file, what you want to do is you want to define what are the aggregations that you want to calculate. So one aggregation could be count the number of views in the last minute for every product. So you're going to count every 1 minute, and you're going to update that counter every 5 seconds. So every 5 seconds, you'll look back in time for the last minute. How many events have I seen for every single product? And the same is, with 3 or 4 other aggregates. So another one that you see on screen here is the average price. What is the average price for every product in the last 24 hours? Updating that counter every 5 seconds. And you can see the same views in the last 5 minutes or views in the last hour. So those 4 aggregates are what we're calculating for every single product. We're going to store, that value is going to be continuously calculated and stored in memory in a data structure called a product view map. And so the code that we'll be generating will be connecting to this Confluent Kafka topic. So here on screen, you have some basic information on how the code will connect to Kafka and how the code will deploy, where the code, the Hazelcast code will be deployed to. So in this case, we're going to be using Viridian, which is our fully managed Hazelcast offering in the cloud. So without further ado, so now that we have an understanding of the page, how the events look like, what calculations do we want to do, let's now just generate the code and deploy it to Hazelcast. So what I'm about to run is what we're is the centerpiece of all of this. So what we're saying, CLC is our command line utility. So this utility in the new version that will come out soon, you will be able to create a project for declarative events aggregation, and you will be feeding it that YAML file that we saw earlier. So with that, that's all it needs to generate code. So if we look at what has happened now, you will see a new directory in place there. So let's have a look into that directory. Here you will see that a number of files were created. So including in the source directory, the Java code that will be deploying to Hazelcast. So let's compile that code. With that, we'll just compile that code. And now let's deploy that code to Hazelcast. So that deployment, we're just about to deploy that code. It's a deployment script, and it was automatically generated as well from that YAML file. So now this code is being deployed to a Viridian instance running in our cloud. So let's look at what that Viridian instance looked like. So may move a little bit the zoom bar. It is. So what you're seeing now is Viridian is our, as I mentioned, our fully managed way of creating Hazelcast clusters in the cloud. You can see the details of one cluster, the cluster that I'm submitting my code to. And for those of you that are not that familiar with Hazelcast, what you're seeing now is the admin tool called Management Center. And you can see that we have a cluster. And in this cluster, there are 3 members. So there are 3 compute devices where each of them has 2 processors and about 1 gig of memory. So we have 3 of those in this cluster. We also see that you have a section with storage. So this is where data is stored in memory. So using the memory of those 3 nodes, and likewise, you have stream processing where you have jobs. And these jobs, that piece of code that was generated is now running here in Hazelcast. And as you can see, here's a graphical view of what the job looks like. And you can see that events are coming in from Kafka, and then immediately they go into a set of parallel streams of processing. Each one of these streams is calculating each of those aggregates that we saw in the YAML file. So what is happening is as events come in, they're separated and split into these 4 aggregates where we're calculating those aggregations. And the last step in each of those parallel streams is to update a data structure in memory that keeps hold of all of these aggregates. As you can see, there's the job is deployed, but so far has not received any events in the last minute, as you can see on the screen. So now let's fire some events and start seeing what happens. So I'm going to be using a Jupyter notebook just to show that this is nothing too complex. We're just reading some test data. We're loading into a Kafka topic, and we're going to be sending up 200,000 events. And I won't spend too much time because this is relatively straightforward. So let's run all cells. And if I switch back to Hazelcast, then this job, as you can see, is already listening, is starting to receive events. So you can see the number of events are coming in per minute. Each of those events, as I mentioned, is taking part on, is being feed into these 4 calculations, and then that counter is being, those counters are being updated. So where those calculations are going is in a map data structure, which is a key value stored, and you can see that there are 10 entries already here. To have a look at what those entries look like, we could run a SQL query to see what does the data look like. And immediately you can see that for every product, we see each of the 4 calculations or aggregations that we defined in the YAML file. I can refresh that query. You can see that those numbers are changing. Every 5 seconds, each one of these events is being fed into the calculation of each of these aggregates, and that number will continue to increase. So that's fine. So far, we've seen that something is happening in Hazelcast, but ultimately, this is not where your users are consuming your app. So I built a little app that will show how this data could look like. How do we display that data that now is in memory, that's been continuously updated? So if we look at this app now and choose any of those products, you can see that for each of them, we may have an image, and you can see the basic information that you will need to push those messages. So this particular beautiful city, there are 5,336 views in the last minute. You can see the views in the last 8 minutes are going up, and the same as in the last hour. That's the average price. And the same is happening to every single product. The views are going up, or they may be coming down in the last minute if there are actually no activity associated with them. But you will see that every 5 seconds, these counters are going up or down, depending on the activity that is happening. And this is kind of the secret of how you will build a solution that performs all these calculations in near real time. The calculations are stored in a low latency data store, and then can be easily served to an app that is just displaying those values and being updated every 5 seconds and at a time frame of your choosing, to be honest. So this is it. So this is the demo. So for us at this point, if there's any questions, I'll be happy to take them about the demo. If not, we can also take questions at the end, if that's okay.
Yeah, sure. So let's just keep questions towards the end. So you keep going, and then we collect the questions and send it like once we finish. Excellent.
So what you saw in this demo is that this is a declarative approach. So there was no code, or there was only the YAML file that you needed to have to specify what you wanted to aggregate, and what calculations you wanted to perform on which events, what is the source, what is your Hazelcast, and we'll do this. This utility will generate the code and submit it, and help you to submit that code into Hazelcast. So we saw, I think in the demo, we saw probably about a couple of thousand events per second on a very, very low spec cluster with 3 members, 2 CPUs, 1 gig of memory on each. But you can get a picture of this will scale. The more hardware, the more powerful members you add, and the more numbers of members. As you increase that, you will be able to handle a lot more throughput. And this is, the scalability point is one of the highlights of Hazelcast. You can, in a single cluster, you can scale both your compute and the low latency data store, and you can tune it up and down depending on your on the activity that your app is receiving. So we've seen Clickstream, which is kind of a very simple way that we experience real-time event aggregation in our everyday life. But there are many other use cases. When you think about the pattern of counting events that happen over a recent period of time, you can clearly see that cybersecurity is an area. So a large number of suspicious activity over a small period of time is a good indicator that something is going off. Likewise, we saw this clickstream, and we can extrapolate that using that same real-time information to feed into inventory management and forecasting systems to figure out what is the right level of stock that you need to sustain of each product to meet your demands. And in the world of AI and machine learning, a very common use case is streaming features. Streaming features are calculations based on real-time activity. So how many times have you seen or clicked or bought or added to a cart or used your credit card in the last 5 minutes or in the last hour? What is your average spend for the last day or so? Each one of those points could be an indicator of suspicious activity. That aggregation can be fed into machine learning models to produce a prediction of how likely you are to convert, how likely you are that you are committing a fraud, and essentially many other use cases. And in this new world of large language models, LLMs, we know that they produce good answers, but if you feed them the right, with a prompt stating what is your current usage of a particular product or real-time activity that you're aggregating, then the answer becomes more relevant. It's not the same to ask a product assistant to help you with a question when this product assistant actually knows your usage of the product and can be more detailed in its answers. So real-time aggregations are used to pass real-time context into LLMs and make their answers more, in a way, personal to whoever is using it. So these are all examples, and there are many more, but essentially whenever aggregation of real-time activity happens, you can think of potential use cases here. So next steps. As you can see, we have this declarative event aggregation capability. Is now the MVP is ready, and I'm looking for developer feedback. I would love to have one or many of you to use this feature, and that will help me prioritize what gets shipped. We will go ahead and release this early in the new year. So if you're interested in getting your hands dirty with this, please reach out to Fawaz or me. And also in the new year, look out for a video series where I would walk through exactly what I did today, but in a way that you can follow along. So again, if you're interested, reach out to Fawaz and myself. Also, as Fawaz mentioned, and for those of you that are not that familiar with Hazelcast, it's worth investing in researching a little bit more. So we're super happy to announce that we were chosen as a strong performer in the recent Forrester Wave Q4 for streaming data platform. So the report is out, and you can get I think we can share a link on how you can get this report. And finally, I would like to thank our marketing team that made everything happen and everything look so seamless to many of you guys. So this event was jointly held with the London Java community. So there was a lot of logistics that needs to happen for this to go this smoothly. So thanks to our marketing team, and Fawaz, again, you're our developer advocate, and also to Yushe, my engineering partner in crime. His technology for CLC is what allows developers to build some of the stuff that I show you today. So thank you,
Yeah,
everyone.
that's great to hear. Yeah, thanks so much, Ed, for your presentation and for the demo today. So for anyone watching us live now, feel free to type in your question for Ed or about the demo or about the code, about the concepts or about using Hazelcast. I think the most important factor here is the developer experience, right? So being able to create such a pipeline without going into the details of creating this pipeline and spending many hours. We all know how hard it is to create such pipeline. So can you comment a little bit, Ed, on the user experience here? How easy it is basically to create such an application?
Yeah. So, well, as you saw it, the experience is super easy. Once you have this YAML file, all it takes is one command to generate the code. But what I didn't show you is what this code looked like. And when you see it, for those of you that actually get your hands on this, you will see that for that little example that we saw, it's more than 500 lines of code that get automatically generated for you. And that's not including some of the unit tests. So it's still finalizing that part. So by the time that you realize you're already into thousands of lines of code just to generate, just to be able to do what we've seen on this demo. So yeah, user experience is a big part. We want to simplify deployment and how developers use Hazelcast. We know stream processing is still very specialized. It's only a subset of people who understand what stream processing is, but the concept is fairly general, and some of the most common use cases are relatively simple. So we'll continue to invest, and you will see us building developer features that will just aim at this. How do I simplify deployment of these common use cases?
Yeah, this is great to hear. So Hazelcast offer training basically and essentially education as well as badges. So yesterday we had a session with our director of education. If anyone interested in using Hazelcast, we have a Hazelcast essential course. So feel free to sign up for this course. You will get badge. Also, you get hands-on experience with Hazelcast. But going back to the demo today, Ed, we've got a couple of questions if you don't mind. So one question is about the JSON format. Does it have to be in JSON format for the actual input here?
Yeah, at this point, this is built with JSON format in mind. It's a very common format used across the industry. But for the Java developers here in the audience, the code that gets generated, you can tune it and you can use a serialization mechanism of your choice. But you will have to today you will have to complete that serialization part in the code. But one of the features that I see coming up is using that serialization and reducing, making it easier for Java developers to use other formats other than JSON, use their Java serialization mechanisms. So we're looking into that. If you have feedback, that will help me prioritize that over anything else. So, but yeah, we
Sure.
JSON as a good starting point.
Yeah, sure. So anyone is basically want to replicate as its demo, feel free to reach out to Ed or myself, or even leave your questions on our community Slack. So I got a question about Hazelcast deployment. So can I use Hazelcast in a Docker image basically to run the same application?
Absolutely. So Hazelcast, what I showed you today was our fully managed cloud offering. But yeah, Hazelcast can be run in a Docker, and this declarative event aggregation will also run if your Hazelcast is running in a local machine in a Docker setup. And also Hazelcast allows you to self-run your own clusters, and you can use Kubernetes technology, for example, to deploy your own Hazelcast instances. So yeah, so you can go from the simplest, from Docker, all the way to Kubernetes style deployment, and and also our fully managed service. So yeah.
So yeah, that's great to hear. A couple of options, basically we cover it all. We had UJ a couple of days ago about the CLC, and to be honest, it's one of the most useful tools when it comes to creating such great pipelines. I just want to touch on the pipelines and the job, basically architecture here. So what is the recommended approach here? So is it a single job for compute or multiple, or, can you just describe or shed some light on the pipeline?
Yeah, and what you saw here is a single job that performs 4 calculations in parallel. So you might think, is this the right way to approach this, or do I need multiple jobs doing multiple calculations and split that load? And I would think that the sort of the best practice is, if you have, it depends on your time granularity. I was updating these counters every 5 seconds, but not everything needs to be updated every 5 seconds. If you have events that you want to aggregate in a different time window, say 5 minutes, 1 hour, 1 day, then you may deploy a job that looks at all of the aggregates in that time window, and that would be sufficient. That will reduce the load on the more sensitive ones, and because you'll be dealing, if you want something updated every minute, that will consume more resources, and you don't want to be calculating that while in parallel trying to calculate something every 5 minutes or every 10 minutes. So you can't. One way of doing this is to separate, your jobs for each kind of time window that you want to aggregate. That would be one way.
Mm-hmm. So this is great. So this is one way of approaching it. It's basically the time frame for doing the aggregation. Can you describe a little bit about the throughput? Is there a way to increase the throughput here?
Yeah. And there are multiple ways. So the obvious way is to add more. So you saw that in this cluster, we have 3 members with very, very low speed, 2 CPUs, a little bit of memory. Naturally, the more Hazelcast will make use of additional resources if you provide these members with more resources. So that means if you increase the number of CPUs and increase the memory, you will expect to see higher throughput. Another way, of course, is to increase the number of members. So as a clustering technology, we can support multiple members running. So you can have 5, 7, 10, 20 clusters. So large production scale deployment is usually around, could be anywhere in the 20s or 50 members for each cluster. So you can spread that load across more machines, that each of them are more powerful. So as you scale up your hardware, the underlying hardware, you should see throughput increases.
Yeah, so this is great to hear. So again, anyone watching us live now, feel free to sign up for the DevRel campaign. Today is the final session, but we're still accepting registration because we're gonna send the whole 12 days basically by email, and we're gonna ask you for a community survey as well. So we'll get linked down below. So make sure to sign up for the DevRel campaign for a chance to win $500. And with that being said, I want to just thank the London Java community for hosting this event. It's a great pleasure to work with you guys. Anything you want to add, Abby, at this point?
I don't think so, other than obviously feel free to find us on LinkedIn, and you can find us on YouTube as well. So if you want to see recordings of events like this one, you can find them all there, and you can join the Slack group as well through our website, which is London Java Community. It's really easy to find.
Thanks so much, Abby. Before I let you go, Ed, is it all right to ask you rapid questions here? Fun questions, not technical questions.
Okay, yeah.
Sure. So, coffee or tea for you?
It's tea, definitely tea.
Tea. That's good. Favorite music band? I know the answer.
I would say Metallica, but that's an unfair question. So many of them.
Okay, morning meeting or afternoon meeting for you?
Morning. I'm a morning person.
See, this is like a point where it clashes. Like I had a couple of guests like a couple of days ago, and they are based in the US, and they said also morning. And my question is, how do we combine the morning sessions or morning meeting in the UK and morning meeting in the US? So maybe lunchtime or around lunchtime. So favorite movie or last movie you watched?
Not into movies.
No. Last book you read?
Oh yeah, The Coming Wave, a book by Mr. Suleiman, who is a visionary. He's the CEO of Anthropic, and the book is just amazing. It's just about innovation and how currently we're living in an era where the combination of multiple technologies will see an acceleration of progress. You know, what is projected to happen in the next 5 to 10 years is probably faster than whatever happened in the last 50. So yeah, it's a fascinating book. Definitely recommend you to read it. Even if you're into science fiction or even reality, this is a great book just to help you picture what might be coming in the future.
That's my Christmas present sorted now. I know I I want for Christmas. So I just want to thank everyone watching us today. Thanks so much for joining us, tuning in today. We have a large community on Community Slack, so feel free to sign up for Community Slack as well as Twitch. Also, make sure again to sign up for the DevRel campaign. And with that being said, thanks so much, Ed, for your time here. Any final words or any final thoughts you want to share?
Nothing at this point. Let me know if you enjoyed the demo and reach out, and looking forward to your feedback. That's what.
Yeah, that's great to hear. Thanks, everyone.